Hello, hello. Can you hear me?
Yes,
Okay, okay. So, how are you?
I'm okay, Professor. I'm okay.
Okay. So today is our fifth number of class. I will take the fifth number of class, and we already covered our first class, second class, then third class, and fourth class. Okay. Today is our fifth number of class, and this fifth number of class, mainly in this class, I will try to focus on air quality monitoring. So how you can easily using the remote sensing technique and monitor the air quality. And suppose you want to how we can easily make the time series chart of air quality parameters, then how we can easily make the monitor the different types of air parameters, suppose sulfur dioxide, nitrogen dioxide, carbon monoxide, or other gases, how we can easily monitor. And finally we can also try to calculate the total estimation in a particular time period, how many gas will be emitted in a particular time period for a specific region. So I hope you can easily understand all of the topics today. So mainly today's class, I mainly focus on the air quality parameter. So let's go. Okay. So I simply share my screen. Just a minute. Okay. So now can you see my screen now?
Yeah, I'm seeing your screen.
Okay. Okay. So hi and welcome to the 7 days online training session on Google Earth Engine for beginners to advanced level. So we already covered our 4 classes, and today is our fifth number of class. I am course coordinator. So today mainly I will try to focus on air quality parameter, how you can easily monitor the different types of gases for a specific region using the remote sensing technique. So here you can see today is this is our course module. So this is our fifth number of course module. So in this course module, first of all, I will try to discuss about that how you can easily create the or monitor the density of nitrogen dioxide using the Google Earth Engine platform, and how we can also easily created the sulfur dioxide. Actually, all of the gases. This is the same procedure. When you want to learn one gases, then you can easily do for the same process and easily monitor the sulfur dioxide, nitrogen dioxide, carbon monoxide, or any gases you can easily do. And then we also try to focus how you can easily download the air quality parameters time series data in CSV file format using the Google Earth Engine platform. And then we also try to learn about the some conversation. Suppose how we can easily convert the unit from mole to meter, mole per meter squared to molecules per centimeter cube, like this conversation unit we also try to discuss. And finally we can also try to discuss about that how you can easily make the time series chart of air quality parameter. Suppose you want to how you can easily make the nitrogen dioxide, these gases time period chart you want to easily do. And finally how you can easily export the map and use the ArcMap software for making the map layout or other things. Okay, and you can see here first of all you can see this is our 2 map in here. So mainly this map I created for my research purpose using the Google Earth Engine platform. First map you can see it represented the methane concentration map of Kuwait, and you can see this unit is the parts per billion or ppb. Okay, and this is the methane concentration map, and this is the another map you can see the nitrogen dioxide concentration map year of 2020 month of January. So we can observe the nitrogen dioxide concentration map for whole Bangladesh. So here you can see this is the unit for nitrogen dioxide. Here we can easily get the value This value is the mole per meter square in this time, this unit. So I hope after completing this today's lecture, you are able to do make map like this. How you can easily make the map like this for the different types of gases map. You can easily make this. Okay. So then you can also see this is the another research tasks we can mainly do for the research for the rebounds of nitrogen dioxide in Bangladesh. We can observe the nitrogen dioxide before lockdown, then during lockdown and post lockdown for Bangladesh during the pandemic situation of corona. Okay, so we can easily, this is another research part. We can also try to make all of the things using the Google Earth Engine platform for data processing or other things. We can easily do the Google Earth Engine platform. And then finally, we can download the data as a TIFF format and make the map layout or other things using the ArcMap software for our research paper as well as also our presentation work. Okay. So let's go. So first of all, in this time, here we use the Sentinel-5 for monitoring the air quality parameter. So mainly this Sentinel-5, this is the satellite, and this satellite sensor record the air quality parameters. Okay, so in this time you can see this Sentinel-5 is focused on air quality and composition climate interaction with the main data products being ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. We can easily observe all of the condition. Okay, and this is the main link for this website of data set. We can simply go to this link and we can easily access all of the data. Okay, so in this time I simply go to this link and try to show you all of the data about the air quality parameter. So I simply copy this link from here and then I simply just open my a new code. I simply just paste here this link. So now we can see all of the data set about this. So here you can see this is the Sentinel-5 data set, and this Sentinel-5 is the mission for the instrument collect data useful for accessing the air quality parameter. We can easily access in here the ozone, then methane, also we can easily access the aerosol, carbon monoxide, then we can also use the sulfur dioxide. Okay, so here you can see, and this dataset provider is the, you can see, Copernicus European. You can see this is the European space. Also you can access the carbon monoxide, formaldehyde, then nitrogen dioxide, then ozone, then also you can see sulfur dioxide, methane. Okay, we can easily work with this and we can easily get the different types of data processing we can easily do. If you want, you can also easily make the time series chart. If you want, you can easily make the map for your own region. If you want, you can also calculate the specific region for a specific time period, how many particular gas is emitted. We can also calculate the value. Suppose how many nitrogen dioxide gas is emitted in Bangladesh year of 2020 month of January. You can easily calculate the value, how many gas is emitted in a particular time period for a particular region. Okay, so in this time I will try to show you that how we can easily do this. So I simply open my slide, then we'll try to discuss again. So I simply open my slide. So in this time I will try to discuss about that how you can easily import the data from the Earth Engine dataset, then how you can easily filter this data, then how to do reduce this image collection, and then how to clip on your shapefile, and how to display the result on the map. Okay, so I will simply open my code editor and try to show you all of the things practically so that you can easily understand. So I simply open my new code editor in here. I can see this is my code editor. I simply open my code editor. First time I need to import this data set. Okay, suppose in this time I want to work with the sulfur dioxide. I want to create the map for the sulfur dioxide for year of 2019 or 2020. What year you want to need, you can simply work with this. Okay, In this time, I simply go to my data set and I need to find out the sulfur dioxide. So I simply, you can see this is sulfur dioxide. I simply click here. So mainly this data set, from this data set I can easily get sulfur dioxide. Okay, so here you can see this is the data set availability date. We can observe this time period. We can access this data from this data set between this time period from the year of 2020, from 2022 3rd July. Recent time you can see July, 3rd July. We can get this data, and you can see this is the dataset provider is that European Union, ESA or Copernicus. They are provide this data, and also you can see this is the unique ID of this data, Earth Engine snippet. And we already know about that. When you want to import the data set, we need to just we need to simply copy this Earth Engine snippet and paste on our code editor. Okay, so I simply copy and then simply paste in my code editor. So here network connection is not so good, so that's why it takes some time. Okay, just a minute, we wait for opening our code editor. So just a minute. Okay. Okay, so now this code editor is opening. Okay, so now I simply paste in here. Okay, just I simply paste. You can see this my collection. All of the collection is pasted in my code editor. I simply put a variable name in here. So I simply take a variable and give the variable name is the SO2. You can use any variable name. Okay, so now you can see this data set is imported in my code editor. Okay, in this time I want to just filter this data set according to my time period, according to my boundary. Suppose I want to observe the sulfur dioxide, this gas, for the Bangladesh region. Okay, so I simply import my country boundary shape file, and we already know about that how we can easily import the country boundary shape file. So I simply open my country boundary shape file Bangladesh from here. So I simply import. You can see this is my country boundary shape file. I simply import, and then I simply put the variable name is that suppose this is my ROI or region of interest. I want to make the sulfur dioxide concentration map for this region of country boundary of Bangladesh. Okay, in this time I simply take a variable. I simply take the variable. Suppose this variable name is that image. I simply take the variable name is the image. Okay, you can use any variable name. Then I simply call my full collection variable name. This is my collection and it is stored in a variable. This variable name is the SO2. I simply copy this variable and paste here. Okay, and then in this time I want to simply use here the filter bounds function. And what is the filter bounds? Filter bounds is a function. It intersecting with our collection with our region of interest. In this time my region of interest is that ROI. I simply put here the ROI. Okay, then I also need to select the specific band of this data set. Here you can see this data set has some band. You can see the first band is that sulfur dioxide column number density. When you want to create the density map of sulfur dioxide, then you need to use this band. Okay, so this is the band. This band is the ratio between the sulfur dioxide vertical column density at ground level Okay, and calculating using the DOS technique. So this is the technique, which technique they are collecting the sulfur dioxide gases. They are using this DOS technique. If you want to know about the more details about this technique, you can simply search on the Google, then you can easily get about the technique. And they are mainly in this time, this is the vertical column density at ground level data, and this data they are calculated using the DOS technique. Okay, in this time I want to use this data set, so I simply copy this band name, and then I simply use a function. This function is the select, for selecting my specific band. So I simply select my specific band, select, and then you can see, and I also need to select my specific time period. So I simply use here the filter date function. Okay, filter date. Suppose I want to observe the sulfur dioxide for year of 2022. I simply put my date, year of 2022. Suppose 1st January. Okay, then I also put here the in date. Suppose year of 2022, 1st January 31. Okay, I want to need only for the sulfur dioxide data for 2020 1st January. Okay, so only for the January, month of January I want to need the data for year of 2020. Okay, so I simply put this date like this. In this time I want to check how many images is available between this time period for my region. I simply use here the print function, and then I simply call the image, and then simply paste here, and then click to the run. So now you can see it will provide me the information about this. We can get here the total 416 images for my region of Dhaka city, only for the Dhaka city, and month of January year of 2022 I want to get 416 images. Okay, and you can see what is the duration, time duration of these images. Here you can see all of the images. You can see 2nd January, also you can see 2nd January, then 3rd January, all of the images you can see 3rd January, then also you can see some images take the 4th January. So there are the lot of images. Okay, in this time we need to reduce our image collection. So this is the image collection. We can get the total 416 images, and in this time I want to need to reduce this image collection. So we can use here the different types of reducer for reducing this image collection. So in this time I want to use here the reducer. I want to take from all of the 416 images, I take only for the average pixel value result. I simply use here the mean. So it will be provide me the average pixel value result, and then I simply use here the clip function, and then I want to clip with my shapefile. My shapefile is that ROI. Okay, so in this time I simply show the result. I simply use here the map.add layer function, and here you can see when I can get all of the argument. In this time I want to show, simply copy, this is my object, simply copy and paste here. And visualization parameter I want to add the letter, so I simply copy and then click to the run. So you can see a new layer will be added here. Okay, but I did not see this result. Okay, it's showing the United States. So for this I simply just focusing the center of this shapefile. I simply use the map.center object, with my region of interest, and zoom level is the 10, and then click to the run. So now we can see it will be provide me the data about my country boundary, month of January, year of 2022. I want to get the concentration map of sulfur dioxide. So here you can see this data set will be loaded, but here I can see I can totally get the black color image, because I get the black color image because I did not have any visualization parameter. So in this time I simply copy this code from here. I simply copy, and then I simply paste in here. So just paste. In this time here you can see that created a dictionary. In the dictionary they are put here the mean pixel value. The mean pixel value of sulfur dioxide, it will be start from the 0 mole per meter square up to 0.0005 mole per meter square. and here you can see the low value it's showing the black color, and also you can see high value of the sulfur dioxide is showing the red color, and that is the sequence of color. Okay, so I simply copy it is variable name from here and then simply paste after the object name and then click to the run. So now you can see what happened. We can get the sulfur dioxide map for year of 2020 month of January. So here you can see this data set for the whole country file. We can easily identify where is the sulfur dioxide is the high and where is the sulfur dioxide is the low in the month of January year of 2022. Okay, so here you can see this is my final map. I can easily get the final map in here. So we can easily export this map as a TIFF format, and then we can finally make the map layout or other things like this. Okay, you can see we can easily export this map and we can easily create it like this map for in using the ArcMap software for like this map. You can see we can easily create it all of the for our research paper as well as also our presentation work. Okay, so here this map represented the sulfur dioxide concentration year of 2020 month of January. Okay, so in this time you can see this is our map, and in this time if you have any question you can ask me about this, any question or any doubt for this you can ask me any question or any doubt. If you have any question.
So, yeah, Professor, what if I intend to change the color and I don't want to use the dictionary color? I want to rewrite my own colors.
So I don't understand.
I'm saying, in case I want to change the colors that
Okay.
inputted from the dictionary.
So mainly you can see this is the colors. Okay, and in these colors according to showing the mean and max pixel value. So here you can see this is the black. So all of the black, this it identify this pixel value for the 0.0. Okay, and there is the very low sulfur dioxide. Then I use at the blue. So this is the greater than blue. Which pixel value is the greater than 0? It's showing the blue. And which pixel value also greater than it's showing the purple. Which pixel value also greater than this? It's showing the cyan color. When which pixel value also greater than this is showing the green color. Which pixel value also greater than the green pixel value is showing the yellow color. And which pixel value also greater than the green yellow is showing the red color. So red is our highest and black this is our lowest nitrogen dioxide concentration. Sorry, sulfur dioxide concentration in this map. Okay. So if you want to check the results, suppose I simply click the inspector and then click on this red color, you can see what happened. We can get the value like this. You can see I can get the value for 0.0092, and when I click on the any suppose black color, you can see what the value I can get. I can get negative. You can see actually this is the very low sulfur dioxide region. Okay, when I want to click on this, suppose in here you can see it also showing it is the green color, so it also greater than the black color. Okay, so black color is the negative pixel value. Actually this is the color, and these colors identify where the sulfur dioxide is the high and where the sulfur dioxide is the low. If you want, you can also change it. Suppose I want to show my color like my own way. Suppose I simply remove all of the color. You can use your own color. Suppose I want to show the all of the low sulfur dioxide place. I want to identify this is the suppose blue color. Okay, and then I want to also show here the another color. Suppose all of the greater than blue. I want to show this pixel value showing as a suppose pink color. Okay, suppose then I also want to show all of the pixel value which greater than the pink color. I want to show suppose this pixel value showing the white color. Okay, suppose then I also want to show the highest pixel value showing as a suppose red color. Okay, when I click to the run, so now I can get the map according to this color. Okay, you can see. So this is a totally is your visualization. So it's totally different on our visualization. You can see. So now you can see I can get the map like this. Okay, which color I want to set here? Blue color it's identify there is the low sulfur dioxide, and pink color is the greater than the blue color, and white color is the greater than to the pink color, and red color is greater than to the white color. Okay, so I hope you can understand about ArcMap software, and from the ArcMap software you can easily add your own color, which color you want to need, you can easily add this color. Okay, also you can make the map like this. Okay, or you can add the legend or other things, you can easily do it. Okay, so this color is totally different on your own choice, but you can see this blue identify the low region, and this is the red, this is the highest region. So this is the highest and this is the lowest. Okay, I hope you can understand. Yeah,
Yeah, I understand, Professor.
okay, so in this time I hope you can understand. So in this time I will go to my next slide. In this time, suppose you want to export this map, as a TIFF format, then you can easily work with this ArcMap software or QGIS software and make the map layout and other things you can easily do. And exporting, this is the totally same way. So I also try to show you that, so how you can easily export this. Then we also try to discuss about that how you can easily make the time series chart, and then we also try to discuss about that how you can easily download the data. Actually this, it has a data. Okay, so between the time period, all of the data, how you can easily export the data in CSV file format. And finally we can also calculate it,